So today we are going to look at designing AI-enabled applications. And yes, we are really talking about design, not just the architectural design in terms of the software. Yes, we are going to actually look at architectural design as well, but we will talk about UX design, and we are going to talk about a few principles of AI UX. So by the way, when we are talking about AI UX design principles, just as anything else in the world today, when it revolves around AI, it is still evolving. Um, a lot of these things that we are talking about today, what we are considering the best practice or principles for this or that, you may find that in the next couple of years, we will find that it wasn't the best. So things are changing. In the world of AI, things really move very fast. So that's one thing I want to say, you know. As a matter of fact, I have even suggested that we probably should have a class in AI UX, you know, as part of maybe future CodeCamp. We are still discussing that for now. So we are going to look at design principles, and then we're going to look at architectural patterns for intelligent apps. So, interestingly enough, we've done a lot of that already, but we didn't really kind of bring all of that into some kind of system where we would say, okay, let us systematically list out what should be the proper way of doing things, right? So we just discuss some of those, and then we will look at situations where they apply and situations where they don't. Then we'll talk a little bit about API orchestration and um, prompt templating. So when we talk of API orchestration, it is how would we coordinate the different components of a system, that we want to be able to solve problems for a user, right? And then after that, we will look at a practical redesign. We'll just kind of have a discussion around, what are the things we would do, or what are the things we would change if we are redesigning an existing maybe app that was designed in the days of in the days before we had AI. So we'll just do that as an exercise. Okay, so let's talk about AI and design. So the question, first of all, is why is AI changing the way we design apps? Why does there even need to be a change in the first place, right? Could we not just continue doing what we have been doing when it comes to design and get away with it, right? Why do we need to change how design is done? So the answer to that is because AI has fundamentally changed, you know, what we focus on, especially when it comes to design and even when it comes to the implementation of the design, right? The focus is shifting from having deterministic rigid interfaces to fluid, personalized, and adaptive experiences. The interesting thing is that we have actually encountered this already, even though it has been kind of sneaking up on us without us realizing it, right? So when you talk about things like fluid, personalized, and adaptive experiences, a lot of this didn't start this year or last year or the last 3 years. A good example that I always bring up is recommendations. You know, AI started a long time ago, but maybe we're not really paying attention. We're only really impressed now with things like the GPTs, chatbots, the recent chatbots, the chat GPTs and so on. And then maybe even things like agentic systems now. But we did have AI long ago, as far back as 10 years ago. If you remember things, what we call recommender systems. A recommender system is a system that is able to look at your preferences, your choices that you make, and then it will tell you, okay, you can also go for this. This is very common in e-commerce sites, movie stores, for example, Netflix, Amazon Prime, and all of those places, right? And any other place where there's a large app stores as well, where there's a large inventory of things to choose from. And in order to guide you to make choices, it kind of looks at what you have been choosing and it compares you with others, what others have been choosing. So it can say things like, okay, especially like Netflix, Amazon Prime, all of these movie stores, they'll tell you, okay, if you watch a particular set of movies based on the nature of those movies, it's able to work out the types of movies you like watching. And then it will give you a recommendation like people that watch this movie also watch this other kind of movies. So it's able to pull out um, from, based on prediction, it's able to pull out the, kinds of movies that you may like. Okay. And then the question is, how does it get feedback on whether you actually like it or not? Typically, it comes from the fact that you go to watch those movies. So if you go to watch those movies, it's a validation of its prediction, right? And using that, it continues to build a model. But if you don't go to watch those movies, then it doesn't validate its prediction. So it kind of still adjusts. So over time, you find that it gets better and better in making these recommendations. So this is the kind of personalized and adaptive experience we're talking about, right? The app is adapting to your own preferences, your own needs, your own choices. Okay. So that's one of it. Now it's even getting more. So we are going to talk about other things. Right? And when you look at that difference itself, we are really talking more about the development life cycle has changed because a designer can quickly move from an idea to high fidelity because we have tools that can quickly bring your ideas out. So it is essentially has sped up how fast you can, you know, move from a concept in your mind to a high fidelity design, right? An interactive prototype. So we can do that in minutes rather than in weeks using current AI tools that are available for designers. So a good example is you can actually use prompts now to generate designs. So even though later on you could say, okay, let me fine tune it, right? But as opposed to before where you would have to sit down and draw the whole thing yourself, now you can easily just prompt, fine tune the prompt and you get what you want. So you are now more of a curator and orchestrator to guide the AI to generate the user interface that you want or how you want it to look like. So this is the main um, uh, driver that has now led to thinking about how do we change, how does this change the way we design applications? Okay. We start thinking about traditional software that was deterministic, rule-based, predictable, to now AI-enabled software that is probabilistic. So let me explain that. Deterministic is software where the outcome is predetermined, as the name implies, even though not really predetermined in that sense, but you can almost um, guess what the outcome will be because you coded it, right? So for a certain set of inputs, you can predict what the output will be. That is what deterministic means. Probabilistic means you can no more predict exactly what the output will be. You can only say, okay, it will likely come out this way or that way. Because with AI, there's a certain amount of non-determinism, a certain amount of probability, because you are no more in control of the process that generates the output. It goes into a system, an AI system that can make choices that you may not necessarily control, or certain aspects of the choices that you may not necessarily control. So the output that comes is probabilistic, right? It doesn't always depend on you, right? And you cannot fully control the outcome or the output. You can try to constrain it to fit what you want by, you know, fine-tuning the prompt and all of that, right? But you will not always constrain it to give you or force it to give you exactly what you want, right? Because it's generating that content. Okay. And again, with feedback, it improves. So the more context you add, the better the outcome you get from it. Okay. So that is in terms of you even using the tools to build your interface or to design your interface. But this same principle also applies to whoever is using your application, right? So things like the user experience patterns, we have to rethink it. Error handling, we have to rethink it. Backend architecture, which we talked about last week. Observability, which we also talked about last week. And then this last thing, the trust and safety is very, very important. And I think this is one of the key things that we will have to um, really think about and talk about when we're talking about AI, you know, design and development. Trust. People need to trust the application. The question is, will people trust the application if you cannot control how the AI behaves? So what that boils down to basically is that you have to work out ways to control, because if you do not control or regulate, then something may happen and then you end up with a situation where you have to be rebuilding trust of your users. And we're going to talk about that shortly. Okay. So the key things to think about is that no longer are you just designing flows, you are designing entire behaviors, right? You are designing entire behaviors. So let's look at some of the things. Um, so when we talk about the first one, from rigid interfaces to generative UI, you now have context-aware interfaces. So instead of a static navigation menu, the apps are now more dynamic, right? Apps can alter layout in real time based on the user's immediate goal, behavior, or context. I don't think we've gotten to that point yet here, but this is definitely something that is happening, right? Others are kind of thinking about designs that are more fluid, okay, that are more dynamic, right? Layouts that change depending on the immediate thing the user wants to do. And why is this so? Because you probably want to be able to look at the context from the user, and you don't want the user to start looking for how to do it or where to do it. So you are actually going to improve your interface so that instead of the user looking for where to do stuff, right, or where to click to get to that part of your app that it can do stuff, that part of the app actually comes to the user. So think about For example, I visit an app, right? And let's say it is an e-commerce site, and there are many things you could do on an e-commerce site. You can decide to shop, you can decide to choose products, you can decide to make payments, you can decide to you want to contact, contact us or something to get information. So in our traditional approach to the user interface, what you have is you have a menu and people have to find which menu leads them to that particular part of the site. But we are now going to a place where instead of people clicking links in the menu system to get somewhere, the AI, the site is more intelligent to know what they want to do and brings that page to them instead of them looking for that page. Now, how you work that depends. You could easily say, okay, let's switch the URL or whatever, right? Those are details of implementation. But the thing there is understanding the intent and then bring the page to the user. The other one is an interface that kind of remembers your activity and can bring the page that you are most likely going to visit instead of you having to navigate. So maybe you log into a site and it brings you a page that maybe you always go to the dashboard to check the chat, right? Or even gives you a summary of, okay, where do you want to go? This is the last time you visited, this is where you went, this is where you went, kind of thing. Okay. So interfaces that become aware of context. Then we now have intent-based interaction, which is kind of an extension of what I just said. You are on an interface, so instead of clicking through the steps, you write a prompt that says, I want to do this or that, or I want to achieve this or that. Okay. And then that happens, right? So I want to make payment. It takes you to a payment page. In fact, you can even go to the extent of, well, we're going to talk about human in the loop and all of that because you don't want the situation where there are some things that you need a human approval or human intervention before it happens. So a good example is payments. You definitely don't want an AI making payments without your approval and, ensuring that you're making the right payment to the right um, um, account or whatever, right? So, but there are situations like that. So again, intent-based interaction. So you are even going to see user interfaces where all you have is a prompt box. Where you just type prompts, and that's like I would say the most radical kind of redesign, if you wanted to redesign. I don't have anything. I don't have a menu. I don't have a sidebar. I don't have anything, right? All I have is just a box, like, how Google revolutionized with their single search box on a white screen, and you just type what you want to search, except that this time it's not just a search query, but it's a prompt, and it does that. I've actually seen that something like that in there is this ERP app called ERP Next. If you have used it before, or you can go check it out, right? Everything is based on search. So you just have this very prominent search bar at the top of the page. And, you know, you whatever you want to do, you type it there. So it's not really a search per se. It's more of, well, that one was before this current um, approaches that we have, right? But then it was more of um, which activity you want to do. So it takes you to that page, right? Or it gives you tips. But with modern AI, you could even go a step further. Then the other thing I think we will also consider is voice and natural language. So we can now have conversational interfaces where instead of having a complex form or menu, right? If you needed to do stuff, I'm not talking about forms for collecting data, but forms for maybe um, being able to identify what you want or the context of what you want. You then have a conversational interface. And like I mentioned just now, you can just have a simple input box to type a prompt. Now, the interesting thing with that is that you can replace that or you can enable voice, speech synthesis, speech recognition, right? So you don't even need to type anymore. You just speak and it takes that the speech and converts it into the prompt and runs it. So think of Alexas and Google Homes and all the rest of them, right? And Amazon Echo and so on, right? So it your interface, and this is kind of the future because you now have interfaces where it's more conversational. Conversational interfaces were difficult to implement before because even though you could easily achieve speech to text, which we have done, in this class already, so we know how to do that. But speech to text is not the end of it. The text itself needs to be turned into we needed a reasoning engine that would turn that text into actionable steps, right? And then carry out those actionable steps, get the results, and then give you feedback. So that was the missing loop, the missing part of the loop before. We now have that with LLMs. Large language models now allow you to convert this text into actions. The agentic workflows now allow us to even execute. Okay. So this is the first change. The interfaces change. We change from just rigid interface to generative UI, and then we can have conversational interactions. The second is, of course, for designers, you now have accelerated design workflows, like we've said already. Rapid prototyping. So I would want designers to go look at some of these tools. The vo.dev, right? UIZAD, and Galileo AI. Basically, you prompt with text descriptions, you upload your prototype sketches. Okay, not prototype, just your wireframe. That's what I was trying to remember. Wireframe sketches that you even sketch on paper, right? Or even screenshots. And they can convert these things into code or Figma prototypes that you can then further improve and fine tune. So we already have this, right? For me, my best workflow would be I sketch designs, right? I use any of these tools to generate a Figma prototype and then go edit and fine tune the Figma prototype. And then from the Figma prototype, I then generate the React um, components for front end. That would be like the workflow. And why that is a better workflow than just taking a sketch and then generating React, which you can still do, is that it allows a designer to bring in their own input. Again, the human in the loop. So you keep hearing human in the loop. Human in the loop is a very critical component in AI design, right? You want human beings to be able to still approve. So if we, for example, wanted to have a workflow, well, if I didn't have a designer, okay, no problem. I would just go ahead and just um, do a sketch or even just prompt and design, right? And then generate the React um, from it. But it will give you the image and then it will give you the code, which you can then fine tune. But if I have a designer, I will want the designer to be part of that workflow, the human in the loop. So on the design side of it. So I want to generate a Figma prototype, send it to the designer, and then the designer would take that and work with it, fine tune it, and make it meet our design system because those are things, some of these AI tools don't understand such things. The whole principle of componentization, the principles of um, reuse of whatever the assets and so on. and other design principles. So you want your designer to be in there, do the design system, do the style guide and components and all of that. So we will see this happening more often. Then automation of routine tasks. So these are time-consuming tasks on tools like Figma and so on, naming layers, resizing components for different screen sizes, creating variations and layout designs. So these are things like, okay, you've already done it, okay, but um, it takes a lot of time to do that. Bring AI. For me, those are the kind of things that I'm happy to bring AI because AI this time around is acting like my PA, like my personal assistant, or my personal coding or designing assistant. So I don't need to do all those ones. Let me rather focus on the creative part of things, right? And then let the AI handle the manual part of things. Okay. I just talked about componentization, generation of components. So the AI can generate the UI components based on prompts. It can even give you color palette suggestions. Yes, that's another thing that I always have trouble with. Okay. Even though I notice a lot of AI apps just have this purple violet color palette. I don't know why, but that's the point where designers can come in and make, you know, improvements. Design system rules, like I talked about, and even maintaining your design system. Okay. So the other things that you get is the hyper personalization, which I talked about. So you now have individualized user experience. AI can analyze data, clicks, browse history, your habits, and personalize the user interface layout even more and the content on an individual level rather than for broad personas like we were using personas before. So what this means effectively is that you cannot really be very rigid with your layouts anymore. Um, you want more users to use if the layout is what may attract more users to your platform, especially for different people have different issues, UX issues, accessibility issues. I've not even talked about accessibility, which is where when we talk of conversational interface with voice recognition and voice synthesis or speech recognition, speech synthesis, and a bunch of other things, right? So think of the kind of challenge we have with ALT text, the alt texts. So if a blind person is using some kind of screen reader to visit your site, okay, the ALT text is the only thing they can use to know images, what's in an image, and so on. These days, you can use AI to generate that because images are dynamic. So just captioning the images, okay? You caption the images, use the image caption to generate the ALT text. That's something that will really help blind people, for example. So we now have to start thinking a bit more about being so flexible when it comes to things like layout and so on. Then, of course, the content itself becomes more tailored to the user. So they see their preferences and that improves retention. See, all of these things is you want to increase your retention, your user retention. Then smarter user research and testing. So you can do better usability testing. Your usability testing can, basically become so much better with these AI tools because you are not really going to have to do a lot of the things that were very manual that you were doing. You would be able to delegate to the AI. Okay. Then, secondly, you could even set up AI tools, right, to simulate user behavior and to identify pain points. And then that helps you with your usability testing because even though I would still advise that you go out and get real users, but maybe when you're even designing your usability tests or when you're, testing it out, you can use that. And well, if you have AI tools that have enough data, yes, it's actually good enough. to be able to predict, how users will interact. And so you can even predict, the response that your app will get even before you launch it. Okay. And then data synthesis. So this is a key part, a key area whenever we talk about AI, especially training AI models and so on. But we can also use data synthesis to our advantage, right? When it comes to things like design, because you can take the interviews, reviews, and logs that you get from your app and use it to synthesize additional data, which you can then use, for user research, right? For usability testing and all of that. So that's an interesting way you can apply AI. So there are actually tools that help to do all of this. Right. So at the end of the day, you find that as a designer, since you can actually um, get AI to help you do a lot of things, then you have a lot more latitude to do more. So your role changes, right? You are no more doing the manual work of drawing lines and squares and shapes, right? Or pulling together, um, questionnaires and so on for user research. You can then move to higher levels of thinking, of creativity, right? So you are still going, we end up doing prompt engineering. Essentially, everyone ends up becoming a prompt engineer. The only question is, what is your prompt engineer to do, right? Or prompter. Hmm? So you start thinking from a strategic standpoint. You focus on high level creativity. You focus on user empathy, and you begin to build skills on how to guide the AI. Because one of the things I've come to learn in recent times from using a lot more AI for building my tools and building my apps is that guiding AI is a skill. And I still refuse to use the word prompting or prompt engineering. I prefer to use prompting. I don't use prompt engineering, right? But I think it's more about how do you guide AI? Because like we started off saying, AI is deterministic. You cannot really control its how it what it churns out. You can only really guide it. And the of course the one way to guide it is by use of those um prompts, basically. So you are now focusing on the bigger picture rather than just adjusting pixels, as they call it, pixel pushing, adjusting colors or shapes and so on. So that's the first thing that we see is emergent in terms of the role of designers. The second thing is we start thinking about trust, designing for trust. So when we say designing for trust, what do we mean? AI comes with its own issues, right? It's already kind of coming with the terrain. Like people already are suspicious of AI because of a lot of the stories and everything around it. So you're already going to have difficulty, with it in the first place. So you don't want to make that worse, right? You don't want to make that worse. Rather, you want to give people a sense of comfort that using AI is not going to harm them or anything, right? But this is made more difficult by the fact that, yes, AI is unpredictable and it's probabilistic rather than deterministic. So, as a designer, you have to create an interface that will build trust and show transparency. Transparency is very important. I think it's probably the most important aspect. People need to know what's going on behind the scenes, what is going on in the mind of the AI. And then it should be clear to people when they need to intervene or that they need to intervene. Because you don't want a situation where the AI is making decisions and taking actions when the human being is not aware or has not approved it. So this is what we mean by human in the loop. There are some things that the AI can do, right? Because it's in terms of the impact, it's a low impact thing and it's reversible. So for some things that are low impact and reversible, you could go ahead and say, okay, well, especially if it is, um, something that takes a lot of time and is going to slow down the productivity of the user. You could say, let it go ahead and do it. And then, but even in that situation, it has to inform the user of what it has done. So there is that. Think of it like a RASCII chart, okay? They there should be at least information. But then there are some situations where there has to be approval by the user, and um, there should also be the ability to reverse. For things that are reversible without any cost, I think it is okay. You can design for the AI to go ahead and do it, then inform the user. But for things that are irreversible, they definitely has to be human intervention. So those are some of the principles that we think about when we are thinking about designing for trust, and we'll talk about more of those. So at the end of the day, this table kind of gives us the differences between um, traditional design and how AI-driven design is going to move things. Okay, so we've talked about it already, so I'm not going to dwell on that. Okay, so let's move on. What is an AI-enabled application? An AI-enabled application is basically an application that uses machine intelligence to be able to generate content, to be able to predict outcomes, right? To be able to recommend actions, and then to be able to automate decisions. So if you look at that, this is in a certain hierarchy, right? Understanding language is the lowest. It understands. And it was quite impressive years ago that, oh, AI could understand language, natural language, and generate actionable, uh, you know, um, actions from it. Okay. Then generate content. So AI can also respond and give you meaningful content as well. Then predict outcomes. But at that point, the AI is not doing anything. So the AI is not really dangerous in that sense, or it doesn't have the potential to be dangerous in that sense, because it's not taking any actions. Then the next level is it recommends actions to you, which you can take, right? But when you begin to automate decisions, that is where, we have to bring in a lot of safeguards. So this is a hierarchy of, if you like, call it hierarchy of power of AI. Right. So examples of this, uh, what we typically have in the world today or in tech today, GitHub Copilot is a good example. GitHub Copilot now has the capability of running, fixing your code. In fact, changing entire code bases, writing, new functionalities, new features, and so on, right? ChatGPT can do the same thing, but ChatGPT is a sandboxed chatting interface. So the most ChatGPT would do is to chat with you, give you textual information, or generate content, images, and even voice and video, right? The Netflix recommendations, I mentioned that at the beginning. So Netflix recommendations tells you what movies you can watch based on your preferences and other people's preferences. It gets some kind of prediction, and yeah, you can go watch what it predicts, what it recommends to you. Then Google Docs has a smart compose, which allows you to give it a small instruction, and it composes documents, letters, and so on, emails, and so on, based on that. So then fraud detection system. So typically this would be a kind of system that you want to bring into. So this, allows us to think about questions like, if I was asked to redesign an ERP, right? For example, Salesforce, and make it AI enabled or AI, infused. What are the things I would do? How would I, for example, even bring up a fraud detection system in there? You know, how would it work? How would I design it? Both from a UI standpoint, a UX standpoint, and even the implementation, you know. So these are just examples. There are a lot more, okay? But at the end of the day, the main thing to see is that AI is not the product itself. AI is a tool. It's an enabler, right? So we still need to think about the things that we would use this enabler for, right? And the enabler, AI is an enabler that brings intelligence. So if you have an enabler, a toolkit that brings intelligence, you as a designer have to ask yourself, what can I then apply this intelligence? Or how can I apply this intelligence to improve the tool, the software, the product, the app? Okay, so we have levels of AI integration. Um, so the lowest level, level one, is just using it as a feature. So example of it is, and these are the things we had in the past, okay? So tools and products have had this for years, at least for the last 10 years, 5 to 10 years. We've had text autocomplete, right? Even if you've had any of these phones, iPhones, chatting on WhatsApp, when you start chatting, it kind of gives you potentially what, and they were implemented in different ways. What I would even say is that previously, it was rule-based, hard-coded kind of thing based on looking at previous chats you used to do. Okay. But these days they brought in AI, and sometimes the AI even does crazy things. So text autocomplete while I'm typing, tell me it allows to autocomplete. That helps a user. It's text autocomplete is really great, right, for users because most people don't know how to type very fast. Okay, so they don't need to type the whole sentence. Autocomplete helps. Of course, as coders, programmers, we always had autocomplete as well. In our IDE, as we are writing code, it kind of tells us, how to complete the function calls and all of that. So then spam detection is another example of a level one feature, right? We have that in our email boxes. A lot of us don't know how much spam fall into our email boxes. How many times have you ever checked your spam folder? Now imagine if spam folder didn't exist. You would have a lot of crap, right, that you have to deal with. So spam detection has been there for a long time. They use a lot of heuristics before, hard-coded rules and so on. But over time, as AI got better and better in the last 10 years, I know I've had some spam detection as far back as 20, years ago, right? Um, but it's gotten better and better. So those are considered low risk and high adoption. Low risk because, well, apart from spam detection, the risk in spam detection, which we used to have in the past, is that emails that are not spam would go into the spam folder and you will not find it for a long time. So that could lead to you missing out on, time sensitive appointments, meetings, and opportunities. That is the only downside of spam detection. That's the risk. But at the end of the day, it's still kind of low risk. You know that, oh, I need to go check the spam folder for stuff. Okay. So low risk, high adoption. So this is the first level where the AI is just used to kind of enhance um, existing features on the site, to enhance existing features. All right. So that's AI as a feature. The second level of adoption is you now use AI as an assistant. So as an assistant, um, key capabilities that are in the site, key features that you have or that are on your product, you are able to delegate it, right, to AI to do. So for example, in an IDE, example is a coding copilot, like all the GitHub copilots, Cloud Code, and all the rest of them, right? For coders. And you find that a lot of the AI used as co-pilots or as assistants have been in the area or in the space of coding IDs just to simplify software development and so on. But others also have this. So for example, people who are writing, if you're writing legal documents, if you're writing, letters, if you're writing any kind of documentation, you could have that. So in this situation, the human still remains in control in the sense that you can choose what the AI does and what it doesn't do. You can choose to accept the outputs that the AI generates, and you can still have the opportunity to modify the output that the AI generates. Okay. It's doing a lot more work than just autocomplete, right? It's doing a lot more work, but you still have the power, the user, you as a user, or we as a user, we still have the power to, to a large extent adjust that before we eventually adopt it. Okay. So that's level two. Now, level three is AI as a collaborator. It is now an agent in the sense that it is autonomous. You actually give it things to do and it does it. And there is a lower amount of review of the work, the product of that agent, right? And in some situations, the AI suggests things and then you just approve, right? So there's a little less control, right? It's more of a review process, not that I own it and I still go through it, right? So you just approve and it sends it out. So that's AI as a collaborator. So this is kind of agentic mode now. And then level four is AI as an operator. In this case, the AI basically handles the whole thing, right? The only thing you do as a human in that loop is a post-action review. Maybe you go review logs. So a good example is AI as a customer support on your site. Okay. You don't have a customer support team. You have a support, bot running on your site that is responding to people. It's responding to your users, giving them suggestions and things like that. So you already have a situation where there is no real human in the loop. Well, the human is the user that is, but there are other things where that can happen. But in this situation, the only thing you can really do is go check logs and see what happened, right? So you could do damage control, right? Or you could use those logs to improve the AI, but you cannot really influence what is going on. The only way you can influence is to improve. But for the things that have happened, they've already happened. Trading bots are another good example. So for this kind of systems, you need what we call strong guardrails. A guardrail is basically a control that you apply to minimize damage or to prevent the AI from venturing into areas that it is not allowed to or it has not been tested in. So guardrails, as the name implies, basically are um, safety systems that you put in place to limit influence and impact, you know. So those are levels of AI integration. So you can now see from a design standpoint, the paradigm shift. We had a user, and then you have the user interacting with your interface, right? And then you have the business logic, which sometimes we had coded, sometimes that's really what developers are doing basically. Well, developers build the interface, but they also build the business logic. A lot of the frameworks that we have, like React, Next.js, is really just to extract or abstract out the interfaces, the reusable parts, so that we don't need to spend so much time building those. We just reuse those libraries. But the business logic is really what developers should spend time building because the business logic is what is specific to the application, right? And then the database. But that's still the old paradigm, right? In the new paradigm, you can see that the business logic is gone. We don't have business logic anymore. The business logic is now subsumed into the tools, right? And I talked about tools. So tools are the things that give AI agents capabilities, allows them to be able to do stuff. So what you would normally have put in business logic, you now move it into the tools, right? And the rest of it is in the data. So we then have a reasoning layer. The reasoning layer, that's a large language model that is able to reason around stuff. When the large language model reasons, it determines whether it needs to make tool calls. The tool calls is what helps it to implement the business logic or helps it to get um, results from the business side of things. Okay. And so it makes tool calls, it gets additional data. The data is where it's stored in, you can have um, um, data lakes, right? Databases. You could have knowledge bases and so on that holds the data. Okay. So this becomes a cycle, essentially, where the AI reasons and figures out what it needs, whatever it needs that it doesn't have, it queries it, it makes tool calls. The tool calls will um, provide it whatever capability it needs and data. And this cycle continues until the AI, the agent basically, is able to achieve what it wants to achieve, right? And then after it has achieved what it wants to achieve, it's able to pull together the response. It then sends the response, right? And so the power of this model or this approach is that it becomes very reusable for any kind of business logic, right? So if essentially um, um, the business logic part of it is now handled by AI and then it gives us a response. So this is now the new paradigm. And even though a lot of applications have not been implemented that way, but we will see it slowly moving in that direction. So because of these simple two additional layers that have been introduced, for the user interface needs to make this transparent, this loop, this reasoning loop. So the designers need to understand the reasoning loop and they need to be able to bring that reasoning loop to the user so that the user can see what is going on in the mind of the AI agent. What is it thinking about? What information has it pulled? Right? And all of that kind of stuff. Okay. If you use um, recent GPT chat interfaces, right? The chat GPT, the Gemini, the cloud, and so on, you find that they have introduced something they call reasoning. So while it is thinking, it's actually printing out a whole bunch of stuff. That is basically what this is. That's what this is, right? Or this is what that is. I don't know how to put it, but that is what it's essentially telling you all the steps as the AI is looping through, thinking about what it needs to do, calling out to the tools to do it for it. It's telling you what it is doing. So that's a design um, UX improvement and even a UI improvement. Well, the UI is not too nice. Sometimes for me, the reasoning scrolls up so fast. I want to read what it's reasoning. I want to read it, right? But sometimes it scrolls away so fast. So we probably still need some UI improvement there. But at least the fact that they introduced that before, when ChatGPT was thinking or reasoning, we didn't see what was happening. We just see a single what do you call it, spinning thing, right? But we don't know what's going on. I think the first uh, company to introduce that was DeepSeek or something. They introduced that reasoning thing. So that's really, but it's standard now. So you see that the world is moving towards this whole transparency thing. Let the user see what the AI is thinking and reasoning and doing. Okay. So that's the core design shift. And this is essentially repeating what we've already said, that AI layer introduces all of this. It introduces the non-determinism, the fact that the output from the AI is not always going to be exactly the same. It will change, right? And you cannot fully control it, or you can constrain it, in a particular way, right? Then latency, because the AI is reasoning, is thinking, right? And it takes time. It's not as fast as the rule-based calculations that our apps do. There is latency. So there will be delays. So the question is, how do you design around delays? One of the things that designers, I don't know if designers really think about it, but the best of designers think about latency. A lot of our designers don't think about latency. What that means basically is that when you click on a button, the response does not always come immediately. So during that delay, what are you using to engage the user? What is the user seeing? Is the user just going to wait? Especially in this part of the world where we know network is slow. A lot of our designers don't design for latency, right? Give, you don't make a design of, okay, while I'm waiting. But yet, this is where network is slowest, right? And the interesting thing is that the AI layer, the latency the AI layer introduces is not a network latency, how long it takes for um, the payload to go to the back end and come back, right? But rather how long it takes for the AI LLM itself to calculate and give a response. And then when you add that to the fact that it's actually a loop, this reasoning is a loop. It reasons, it needs some information, it calls for that information, the information goes back, it reasons some more with the new information. So that is also a loop. And this loop is made up of both the network latency and the LLM's reasoning latency. So as a designer, what should I be doing while I'm waiting for the LLM to give me a response? I'll leave that question. So there's also things like cost per request. So cost per request, well, that one is for the user needs to know that um, you are paying for this. Well, there are different models. This is now a business model around the app itself. As you are designing the app, who pays for all this cost, right? Is there going to be a flat? I subscribe with certain, payment plan, right? And then it pays for all of this, or you put in your API key and then you get billed. So these are things to think about. Prompt engineering is another thing. Prompt engineering, people need to learn how to properly type prompts so that they can get the response that they are looking for, right? That still ties back to the non-determinism here. And then evaluation needs. So we talked about evaluation last time. Um, for those who were in that class, evaluation is a way of assessing how well the AI is doing on this particular task that you are giving to it. So, or on any other kinds of task, for that matter. So, we always have to do evals on AI. So, but for me, the main paradigm shift is this, right? We are no more going to be writing business. For now, we may still be writing a little bit, but we are not ultimately going to be writing business logic anymore. We are simply going to be writing tools and rags, tools and rags, tools to allow the agents to do stuff, rags to allow the agent to access data and information that is, you know, relevant to a specific context or topic. Okay, so let's talk about some of the AI UX design principles based on all of these things. First one is good AI UX should reduce cognitive load. So what do I mean by cognitive load? The amount of things people have to think about or remember. Think of cognition as your brain's functioning, right? And then the load, cognitive load is the amount of things your brain has to carry in its head and think about. So the user doesn't need a lot of cognitive load. If you give the user a lot of cognitive load, then the user will not like your site. Um, so you don't want to give the user so many things that it needs to remember or so many things that it needs to think about. Of course, this is a basic principle even in UX, right? Even without AI. Like even without AI, that's why we have what we call to action. The whole purpose of a call to action is a guiding light to the user on what to do in a particular page, right? So you're on a page, the user is on a page, and the user has so much content on the page, so many buttons to click, so many menus on the sidebar, so many links on the top nav, right? Things scattered all over the place. And if you did not differentiate between those things, a user will be confused. Which one should I click? Right? And that's what brought up the concept of a call to action. A call to action is something that stands out clearly, right, to the user so that the user sees, oh, okay, let me go here. At least for a first time user, right? But when you are a power user here, you can say, okay, this particular button, I've not clicked it before. Let me even go and click it and see what happens, right? Or a user that has had time to read the documentation. And then the documentation will tell the user, okay, this and this and this are the things you can do, right? But for a first-time user, that user is basically just confused, right? Now, the interesting thing is that with AI, it becomes even more problematic because there's so much a user can achieve, right? So that principle still remains. The UX needs to reduce the cognitive load. The user should be able to know exactly what to do. There should be waypointers for new users that leads them in the direction of the most likely thing they want to do, whether it is to go and just get a quick orientation on what that site does, or even go straight to do like there are some sites that the primary purpose is just one primary purpose. And that's what a new user most of the time wants to come and do. Like, or a payment site, I want to go and make payment. So don't go and start diverting or, confusing me and sending me to places where, oh, okay, go and configure your email, username, and all of that kind of stuff. I want to make a payment. So just take me through the payment flow and I'm done. Later on, I can go and set up additional payment receivers, all those other additional power user kind of stuff should be hidden the first time, or they should be hidden in plain sight using secondary buttons, secondary, access, secondary menus, and so on. But primary menus, primary buttons should lead me to the main thing I want to do. Then the second thing, which is now new for AI, is it should be able to accelerate the regular task that people want to do, right? It should be able to increase the quality of the decision that the user is making on the site. And then most importantly, preserve user control. AI should not do stuff without users having an input. And depending on the criticality of what the AI is doing, that is also how the human input should be, how large the human input should be. A very critical, irreversible action should be fully requiring human approval. But a reversible small impact action can be automated by the AI. I've said that already. But it should be reported. In every case, there should be clear reporting of what AI has done. Okay. So avoid replacing users unnecessarily in the workflow. Avoid hiding AI behavior. Like I said, everything should be reported and avoid over automation. So the golden rule is that AI should feel like a capability, not a gamble. A user should not feel threatened that there is AI on your site doing stuff. The user should really feel empowered, right, to be able to do more. So one thing, this I picked up from an article on Medium. Most AI products use chat interfaces because people already know how to text. right? So that's a way to start, a place to start, but it's not the end of it, right? Good AI design needs things like being transparent about what the product can and cannot do. Transparency, letting users stay in control and making sure the interface feels familiar. So people expect AI to work like other products they've used before. So we must design with that in mind. So with that, we have the four dominant AI UX patterns. We've gone through those already. We have the co-pilots, we have the chatbots, we have the auto-completion, we have the recommendation. So like I said, I think we've looked at that already, but we'll just go through them. Um, the co-pilot pattern, which is the highest pattern. Well, when we were discussing, we also had the um the pattern where you are delegating, right? So it's more than just a co-pilot, it becomes um a co-worker kind of, right? So but a co-pilot pattern is AI assistant is embedded inside a workflow, right? The AI assistant is context aware. It appears when it is needed. It suggests actions. The user approves and then it takes action. Okay. So example, you have the GitHub Copilot, you have the Microsoft 365 Copilot, you have Notion AI that also has a Copilot. So Copilots are really best for high skill users. In other words, users who have mastered your application or your product and want to do more powerful things with it, right? So, when to use a copilot is when the tasks are complex, when the tasks are multi-step, when the tasks require a lot of cognitive load. That's what cognitive heavy is. The user needs to remember a lot of processes and steps and a lot of things that he has to do, right? And when the task is professional, okay? So you only use Copilot in this. When the task is trivial, don't use a Copilot pattern. By the way, you can actually have on the same product multiple of these patterns, right? It doesn't mean I can only have, it just means that invoke this pattern for this and that, right? So the ideal domains for this kind of Copilot pattern is engineering domains, analytics, writing, design, finance. Of course, you see that it also exists in um, software development and so on. So the design tip is number one, the co-pilots will amplify an expert. So somebody who is already an expert will actually be able to achieve more, right, with a co-pilot pattern, right? Then never let co-pilots take irreversible actions automatically. So I think I've said that already. They have to receive approval before they can take irreversible actions. The second pattern is the chatbot pattern. So the chatbot pattern is like standard, is what we kind of already used to. This is really very useful when information and basically information basis, knowledge basis, right? Where you are the main um, objective is to provide people with knowledge or information or data, right? So you use a chatbot pattern. Conversation, the interface is conversation between you and the AI, between the user and the AI. The strength is it's a natural interaction because people are already used to a conversational approach, and people are already used to chatbots, right? We're already using chat interfaces to interact with other human beings, right? With all of the social media chats tools that are available, right? The queries are flexible, right? And it's great for discovery. So typically on your product, you can use a chatbot pattern to help users identify the capabilities of that um, um, of that product. Okay. The weaknesses are sometimes in the chatbot pattern, it's hard to predict the outputs, right? And they're not good for structured workflows. They can also frustrate power users. So one thing to know is that chat is powerful, right? But it's often overused. The second thing, yeah, and that is because the overuse of chat was because there was a time when chat was really the only reasonable pattern available, right? On websites, on web apps, on different products. So everything was a chat, 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 right? But these days we have more powerful patterns, which we don't always have to fall back to chat. all the time. So the other thing is you don't use chatbots when somebody just needs to click a button and do stuff, right? If people just need to do stuff, don't be using chatbots to interrupt their flow, okay? So if the task needs precision, just give the user a control, a UI control, a button, a form or something, okay? Because especially if it's a power user that already knows what to do. Then we have an auto completion pattern. So the auto completion pattern is the lowest friction, like we mentioned earlier. This is where a user just starts typing and you complete. Auto completion patterns are very helpful in forms, right? It's data because you cannot do auto completion based on nothing. It has to be based on previous interactions or data. So for an ID, for example, you already know what the user is trying to type the name of a function or something. On on apps and websites, right? If somebody is maybe making a booking and is typing something, trying to type the name of a product, for example, an autocomplete pattern is really helpful because the user don't have to start typing the entire name. You can bring up possible products that are on that site, right? As an autocomplete. Autocomplete already exists anyway. You can, for example, usernames or product names, which is pulled from the backend. But you can enhance it for those aspects of autocomplete that require reasoning. That is not just picking from a list. Okay. So a good example is composing. Gmail has a smart compose, ID autocomplete, like I've said, search suggestions, and so on. And autocomplete is really nice because there is no learning curve. It's fast, right? User doesn't need to learn how to use an autocomplete. And well, it feels magical and it has high accuracy. So this has been seen that it has the highest return on investment AI pattern because if possible, start with the autocomplete pattern. So always think about it. Autocomplete is really helpful for users, if not for anything else, to reduce amount of typing that the user has to do. A user will always thank you for reducing the amount of typing they have to do, right? There are those who like to type, people like me, because we've learned how to type very fast, so want to flex it and so on, and want to keep practicing our typing skills and so on. But there are a lot of people that, for them, typing is a chore, right? So autocomplete is a blessing. Then recommendation pattern, we talked about that already. The AI will suggest what the user might want. I really recommend this. I recommend the recommendation. I recommend the recommender. So I really recommend this for designers. Think about it. How do you implement it? And there are many ways, just like the autocomplete pattern, there are many ways you can bring up the autocomplete as the rest of a sentence that is kind of grayed out, right? Or it can come down as a drop down. Okay, it can come down as a drop down, and that's autocomplete, especially if they are different possible autocomplete methods, or sorry, candidates, I should say, right? Now, so I recommend autocomplete, but I really recommend the recommender pattern. Please, designers at the very least, depending on whatever is on your site. If it is an e-commerce site, if it is a site where there are so many things to choose from, right? An e-learning platform where there are courses like, Coursera, Udemy, whatever, right? Don't design without a recommender pattern, right? An e-commerce site where there are so many things for people to buy, right? I still recommend a in fact, any product that you build where there are different options and it's a lot, right? It helps with especially new people to fit in and begin to use your site, right? Before they can start figuring out how to search and things like that. So always think about that, right? And look at Netflix, Amazon. Those are like the two best. In fact, as Amazon is the company that really started recommender on the Amazon.com site, right? And then when Netflix is like the earliest, video streaming, movie streaming site, right? And their recommender is, one of the things that I still like I still follow Netflix recommendations when I go to Netflix to watch movies. Like it's always kind of on point. Even though sometimes, one thing we recommend that is they do it based on your preference. So if I want to try a different set or genre of music or movies rather, I just can maybe just go elsewhere, totally outside of recommendations and try it so that I can seed the AI with new data so that I can recommend new stuff for me in that area. YouTube is another good example, Spotify. So always think about having recommenders on your site. So, but recommenders will require behavioral data. So one of the other things, you have to collect data, you know, on your users. And of course, you have to let your users know you're collecting data from them to use. You tell them you're using it for recommendations, for recommenders, and so on. You do need ranking algorithms. You need to be able to rank your um, offerings, right? You need to either the algorithm AI based or using heuristics or using user feedback, right? User feedback is a really good ranking. Rate this, rate that, rate this, rate that. You collect all that data. You need that for your recommender patterns, okay? And then feedback loops. So one of the downside of recommender is if your recommendations are poor, man, people will not, it destroys trust. So, but this is more of an implementation thing, right? Poor recommendations can destroy trust, but always allow users to correct the system. Like I said, sometimes if I have poor recommendations, I can go off on a tangent, go looking for content of a different type so that the recommender system can adjust. But you should allow, the other thing is don't overflood, don't be too biased. Your recommender system should not be so biased that it doesn't allow users to see um, stuff from other, areas. So there should be a bit of a mix, of random um, stuff from other areas, just to allow users to seed your recommender even more. So we'll now talk about designing for trust. So designing for trust, users must understand what AI is doing. I think I've said all of this, but let me just repeat for emphasis. The user must understand what AI is doing. So you have to find a way to give a user a window into what's going on behind the AI's brain, right? Um, its reasoning loop and all of that. It must also, the user must also understand why the AI suggested a particular thing, right? And when it may be wrong, in other words, when the um, confidence is low, right? It needs to be clear that that's why you see sometimes it says AI responses may be wrong, that kind of thing. You see those kind of disclaimers, and this is something to take note of. You have to put adequate disclaimers on your product if it's using AI so that otherwise you get a lot of lawsuits, right? So take note of that. So some of the techniques that you can use for this is one, you can show confidence indicators, basically an indicator to show when it's more confident of something and when it's not very confident of something, right? Then if it's generating content and it's pulling the content from different sources, there should be citations, right? There should be a way to quote and reference that this is where I got this information and so on. It should allow undo, right? It should allow the user to reverse entirely the entirety of what the AI does or aspects of it, right? There should be flexibility in undo, being able to undo. So before the user, even after the actions have been taken, there should be a way to tell the user, okay, you can change this or you can change that. And then requesting for confirmation. So for critical, non-reversible stuff, there should be a way, a pop-up, something that tells the user this thing is about to be permanently, adjusted. Are you okay with it or not? Right. So trust is very, very key, right? And if you lose trust, it will be really difficult for you to get your users back. You don't want a situation where your users don't come back to your website, meanwhile, or your web app or your product. Meanwhile, the whole reason why you put AI there was to keep them. Okay. Then we have what we call human in the loop. So human in the loop means essentially AI should support decisions. AI should allow the user to be the one to take the decision. It's the same thing that we just said. Is it's you use human in the loop when stakes are high, critical stuff, when errors are costly, um, when it is irreversible, when compliance matters. Okay. So examples, medical tools, financial approvals, payments, and all that kind of stuff, legal drafting. Okay. So the pattern normally should be the AI does a draft, allows the human to see it and make a review. And then once the human has clicked on a button, active button, or something else, some kind of active approval, then that is when the system executes it. So that is all in terms of design. Now we're going to talk a little bit about architectural patterns. So this is now speaking with respect to the software architecture itself. I'm just going to quickly run through this. So we already talked about architectural pattern, what we said. You have a user, and then you have the user interface, right? And then we used to have business logic, but we now replace that business logic with a reasoning loop. Reasoning two calls data, reasoning two calls data, and then the outcome. And that is basically it. And we've talked about this already, right? So the typical flow is that you have a front end, you have the payload, data goes into the request goes into the API gateway. Then you have the orchestration layers. Then the orchestration layer, we'll talk about it, allows you to orchestrate all the different components, right? So you will have the large language model being the first element, the reasoning layer. Then you have the tools, which allow the large language model to do stuff, right? And then you have the data sources, which allows the large language model to get additional information, additional context, additional knowledge for it to either respond correctly or do the right stuff. Then you have memory. So memory is really important, right? And this is for the developers. Memory allows you to retain the history of conversation, no matter how long it lasted, even if it lasted for a year. So, for example, if I use ChatGPT now, the conversations I had with ChatGPT a year ago, I can go back into that interface and I can continue that conversation and it will be able to still remember what we had done. Why? Because of memory. The previous conversation has actually been stored. And we'll talk about some of the ways we do this. But one of the ways to store conversation, we have two ways. We have the short-term memory, which is the memory that you store for that session, what we call session memory. It stores the conversation for that session. Then you have the longer-term memory, which stores it somewhere in a database. Typically, it is going to be a database that is backed by a vector store, a RAG. Think of it like a RAG. So you are essentially taking the conversation that we've had or you've had with the AI and you store it in a RAG. And when you want to retrieve or you want to continue a conversation, you can then retrieve that, right? And load it back in, right? The other way is you can just store that conversation as a sequence, of text, right? Which you load back into the um, into the agent. So it gets that context. Otherwise, without memory, both the short-term session memory and the long-term persistent memory, these AIs will just behave like the grandma that always forgets what you people discussed last week. Okay. And it won't be very useful. People people will run away from your app really quick. So you can now see that um and this is again both for product designers and even developers, that memory becomes a key aspect of the user interface, right? And the user experience and even the implementation. So you always have to ensure that conversations that there is memory. That improves the quality so much, right? that people don't have to come back and try to remember. Of course, if you go look at ChatGPT, Claude, Gemini, and all of that, you will actually see that when you kind of retrieve, click on that link that brings up an old conversation, you see the whole thing there is still there because it is actually stored somewhere on the back end, right? And in order for to improve retrieval, it's also stored in a document database. Okay, so memory is key, and then response. So when you look at this is layers, right? Layers of implementation. So the key architectural components, when you are thinking in terms of layers, you will see that the first one is the model layer. The model is the AI part of it, the large language model, right? The large language model is the one that does the reasoning. It understands natural language, irrespective of the language, right? It understands it. It's able to interpret it, it's able to reason around it. So that's the LLM. Then the second one is the embeddings. The embeddings allow you to store information in a semantic context intelligent or context sensitive or context intelligent or semantically intelligent manner. So that information that are similar will be stored, in a way that when you they retrieve together. Okay. That's embeddings. Of course, we already talked about that. Embeddings is one of the core elements of a RAG, the retrieval augmented generation, which allows you to retrieve information that are relevant to the question that is being asked or the prompt. Then the fine-tuned models, that's the third element of the model layer. So there are models that are trained, but they may not be very good for a particular thing, right? So we still need to, even though you can have RAGs and tools and all of that, but you still need to fine tune the model. In other words, this time you are training the model or you are improving the training of the model. You are adding to the training of the model so it gets better. So that's the first part of the architectural components, the models itself, right? The neural networks. Let me just put it that way. These are all neural networks, right? This basically have to do with neural networks. So that's the model layer. Then you have the orchestration layer. The orchestration layer is where you now pull the model and you pull together all the other things that you can build around it. What we call scaffolding. There's a, you know, a colloquial terminology, the scaffolding around the model. And this includes constructing prompts with prompt templates and all of that. Tool selections. So you have to build a tool and then you have to select the tool, right? So you have, the tool selection itself, choosing which tool to use. Let me be clear on that. The tooling layer itself is separate, that's layer three, but choosing which tool to use for any particular request, okay? Sometimes even the tool selection is done by LLMs, but there are other ways. You can use heuristics, you can use business, logic, and so on to decide. Then the RAG pipelines. Okay. The RAG pipeline is a pipeline that essentially is part of the RAG. It's not the RAG itself, but it allows information to go into the RAG and to come out of it. Then the agents. We know what agents are. Agents are basically large language models that you empower with tools, with tool calls, and with additional knowledge bases from RAGs and other external APIs. So that's the orchestration layer, the scaffolding. And then the tooling layer is the layer where things actually get done, the implementation. Search, right? Like web search, like Google search, Bing search, the search engines. The traditional search engines are actually crawling the web and pulling data. That's actually a tool itself that you now make available to the model through the orchestration layer. The databases also contain information, right? The vector stores, which allow the information to be semantically, related. So the information in database can be semantically indexed so that you pull data that are related. And then the external APIs for API calls. So these are the key architectural components. And I don't need to go through all of this because we've gone through all of this before, right? But I think the most important thing is that a RAG allows the LLM to fetch knowledge it doesn't have or it wasn't trained with. Okay. So that extends kind of the capability and the range, right? It extends the capability and the range of your LLM. Your LLM can begin to do stuff, right, that it wasn't trained on. Okay. Then the pipeline, the RAG pipeline, you have the user query. We've gone through this already. You have the embedding of the query so that we know what information to pull. We have the vector search, which already has a lot of information in it. It's embedded, indexed using embedding, so it's semantically indexed. You can pull that. You pull that data, the related data that kind of relates to the query. You embed it into the prompt, right? Or you inject it into the prompt. Let me use the word inject to avoid confusion with embeddings. And you send it to the LLM. The LLM generates the answer. So the RAG, that's the RAG. It gives you more accurate information, domain aware. There's lower hallucination because you are grounding the LLM's reasoning on actual data. So RAG is there, right? Most things you find that you are going to build RAG and then you're going to put tooling on top of RAG. So then we have the agentic pattern, which we've also looked at, right? Agents are large language models that you have given them two things. One, you give them tools so that, or three things. One is tools so that they can, do more specific stuff. It widens their capability. Then you have data, additional data, which we just talked about. That's the RAG. And then the reasoning loop, which allows them to reason, do stuff, and then reason some more, do stuff, and reason some more until they achieve the objective. And that is the iteration there. So you have planning. Agents allow models to plan, to reason, to use tools, and to iterate. So the loop is always think, act, observe, and repeat. The think is the LLM reasoning. The act is the tool calls. Observe is the LLM now checking the results from the tool calls. And based on the result, it can either give you an answer or it repeats the loop, right? So at the end of the day, the agentic pattern allows autonomy because the agents can do stuff on their own. You just give them objectives. You don't need to give them details of how to do it. They find the detail, the how to by themselves because they have tool calls that help them to figure out how to do stuff and they can reason about it, right? But you now see that what this means is that at the end of the day, everything boils down to writing good tools. If your tools are poor, your agent will be poor. Of course, if the reasoning is poor, the agent will be poor. But these days, reasoning is so good. Tools are the weak point. But as it stands, a lot of people have invested a lot of effort into writing really good tools. But if you're building an app for your company or for your business or for a client, you may find that you still need to write your own tools for that client in order to give the agent those capabilities. So, yeah, use agents when the tasks are open-ended. In other words, the steps to achieve the task are not clearly defined, in which case you want the agent to reason about it and come up with the clear steps. So especially when multi-step reasoning is needed, okay? But for simple workflows where it is clear of what to do, you don't use an agent, you use what we call a prompt chain. You use a chain basically. And because you already know the steps to take, you just program the steps using a chain and you send it in. Okay, so I talked about latency and the cost considerations. Latency basically is, that's because it takes time for your LLM to reason and come up with stuff, right? So you want to be able to address that. The second thing is that, yeah, there's still the latency from network connections and all of that. But that one doesn't bother a lot of, if you have fast network connectivity, it shouldn't bother you too much, right? But it's still something to consider. So for you to address latency and all of those kind of issues, there are standard ways. One way is caching. So caching is some of the things can be cached, like tool calls, for example, result from it depends on what it is anyway. So you're not always going to catch everything, but catch what will not change a lot. Okay. Then the other thing is streaming your responses. So this is what I meant, kind of when I said, what does a user do while he's waiting for things to show up, right? Streaming is a good solution. Basically, streaming is you start sending the response before it is fully completed, right? And this is a standard pattern these days with all of these AI tools, right? You see that, for example, if you put a prompt or a question on ChatGPT, it it begins to answer you, right? It's as it is generating, it is still thinking and generating. You are still seeing it, right? It doesn't mean that the back end has finished generating. The back end is actually still generating. But what the back end is doing is it's sending whatever it has generated so far, and the front end is receiving it and displaying it to the user. So that's what streaming means. It means essentially it streams, right? That's what streaming means. Even in video streaming, when you're watching movies, it's not the entire movie that has been sent to the front end. It's just some portions of it that is streamed and sent. Streaming means it is sent continuously in a stream. That's where that word comes from. So in the same way, that same capability is used with AI and large language models so that you can begin to see the response without having to wait. And I think for designers, it's something to think about, like stream. How do you even stream? It's not everything that you can stream that way, but whatever you can stream, you need to think about and think around how to stream stuff for users. Then use smaller models. So why this matters is smaller models run faster, but smaller models also are not as accurate, right, as larger models. The larger the model, the better its prediction, the better its generation, the better its answers. The answers from larger models are much better, but a larger model takes longer, right? So you need to think about it, and this is from the developer standpoint. There are some things that you send to small models, and there are some things you send to large models. For example, if you want to do embeddings, it's better if you use a small model to do the embedding, right? But when you want to do the reasoning based on the retrieval, you can use a larger model. So think about that, right? Then async workflow is asynchronous workflow. Asynchronous workflow is you don't have to do everything one after the other synchronously. Synchronously means one after the other. Asynchronous means you can send this request, and while that one is processing, you can do another request. But that is in a situation where there are multiple things going on where you don't have to wait, right? So yeah, and the thing is this, right? It is not everything that will need an LLM, right? It's not everything that needs an LLM call. Sometimes you can use heuristics. Sometimes you can just write rule-based logic. Sometimes, there are different ways you can do things. So always think about that. Always remember that using large language models is costly and it has latency. So always think about minimal use, minimizing it. Use it only when it is necessary. Okay, so that is design principles, or rather architectural principles when you are building your stuff. So the last bit, I just want to go through this. So when we say API orchestration, I mentioned it, you are coordinating multiple requests, multiple AI and non-AI services to fulfill a request. So we went through that a bit. Like a user sends a request, and as the LLM is going to interpret that request, then that LLM is going to generate tool calls and ask, okay, I need a tool call to the weather. I need to do a search on the internet. I need to calculate, do some mathematical calculation. I need to query a database for some information and all of that. These are a lot of information the LLM needs, right? The agent basically needs to pull together and generate the answer. So being able to do all of that is what we call API orchestration. You are calling multiple different APIs before you get the answer. So effectively, your backend if you are building a backend, your backend is a reasoning engine. So there are things that you can do, right? We've mentioned some of them, right? The first one is run things asynchronously, okay? So that you don't have to wait. So like if you needed for this a search API to be called a tool call, you can send those as async requests, right? So that they all go out the same time. You don't have to wait for search to come back before you call this. So you have to send async requests. That speeds up the time. And when all of them are back, then you can send a response to the LLM. Sometimes you might even think about other things like can I batch them? If there's no dependency, I can even send this one back to the LLM first. Let the LLM begin to think about that while the other ones are going on. Then there are other things, for example, error handling, like we talked about. How do you handle errors? If the API call fails, do you do retries? How many retries and things like that? Then we talk about templating. Never hard code your prompts. Always use a template. Don't put your prompts inside your code. Yes, I did it but these are toy examples I'm using just for the purpose of demo for this class. But when you're building a production app, please and please do not mix your prompt with your code. Even though prompt can be considered as code, prompt is code. Think about it as, because what is code? Code is just a language you use to communicate with a machine. So we have different languages. We have um, Java, JavaScript, Python, and so on, right? That's why it's called a language. Think of prompt as a different language, right? It's a natural language, okay? We don't mix Python code inside C++ or JavaScript inside Python. We actually separate. Yes, you may see it being done when we are learning it, right? In fact, when I was learning PHP, you see PHP being mixed inside HTML, but there's no framework right now that you see HTML mixed inside PHP, right? Or Markdown being mixed inside Python. They are separated. So Markdown, the main reason is you can apply tooling to help you with, sanity check, formatting, and all of that. So if you put Markdown inside your PHP code, for example, or Markdown inside Python, and I'm running a Markdown formatting tool. What will it do with the Python part of it? Or I'm running a Python formatting tool like Flake 8 or Rough or something, or Black. How does it handle the Markdown? So you always have to separate one language from the other. So prompts are a separate language. So don't hard code prompts in your Python code or JavaScript code. Separate them so that you can run your tooling, on each of them differently. So never hard code your prompts. Use prompt templates. LangChain is very powerful when it comes to prompt templates. Put the templates inside a separate file, like Markdown file or whatever name you want to call it. Pull those in, then you can run sanity checks on prompt templates separately and pull them in, inject the dynamic variables, and then push it out to the LLM. So the benefits of this is consistency, easier to do evals because you can even use those prompts to do evals like we talked about. Version control. You can version control your prompt separate from your code, right? Sometimes you may need to update your prompt, but your code is okay. Sometimes you may need to update your code, but your prompt is okay. And you have safer updates. So treat your prompts as code. Um, yeah, for front end, modern front end should be smarter. You can pre-build prompts. You can manage conversation state. Like we said, the state of the conversation, the session memory, basically, right? You can stream tokens, so you can stream from the backend. You can retry failures. You can show partial responses. So the front end, for front end developers, front end is now part of the AI system, right? it's kind of a separate, separated the front end of the AI system and the back end of the AI system. So the front end is now part of the AI system and has all of these things. That's why most libraries will have both back end. LangChain has a back end and a front end. So you can add the same capability to the front end as well. And then, of course, we have Mastra, which we are going to look at next week. Observability is very important. I will not round up without talking about observability. So observability basically is I need to know what's going on because AI is so different. It's what do you call it? Deterministic. You need to always see what is going on. You need to see the prompts that are going to the LLM, the responses that are coming back. We need to know latency so that we can, fix issues. We need to know the cost and so on. We need to know user feedback. Then for tools, the tools you can use, we looked at Langsmith already. So apart from Langsmith, I didn't forgot to mention there is also Langfuse. Langsmith is not open source, even though it has a free tier, so you can use it. But if you wanted to deploy on your own server an observability framework or platform, you can't use Langsmith. Langfuse, you can use Langfuse. So I'm going to show you a link to Langfuse where you can look at it. So you can install it on your own server. This is in the event that maybe you have a client you are building for and they want observability, but they don't want it on Langsmith. Even though they could still have it on Langsmith, not a bad idea. But if they want it on their own server, then you can check out Langfuse and a bunch of others. I know the other cloud providers also have. Azure has, AWS, and so on, GCP. Yeah, so weights and biases allows you to check prompt layer. These are all tools that you can use to monitor your AI and make sure you monitor its behavior, not just the uptime. All right. So I'm going to, I'm going to, yeah, so like I said, this class is actually a mix for both designers and developers. So this slide is some of the common design mistakes, right, which you would want to avoid. Um, Adding chat when it isn't needed. So let's not always assume that we always need a chatbot on a website, right? You need to ask yourself, do I really need a chatbot here? Or should I do something else? Should I do a recommender, you know, should I do a recommender, right? So let's us not always assume by default, designers, that you always need a chatbot or the chatbot is like always the right solution or the right AI um, element for you to add into a product or a website or whatever. We always need to think about it, right? So that's the first one. The second is if you design an AI system without a human override, there should always be a human override. And take note, human override is also different from human in the loop. Well, human override is part of human in the loop, right? But I could also decide I don't even want an AI. I want to just do this all by myself. A user should be able to have that capability, right? So don't constrain people to things that they cannot choose or they will not have a choice. Okay. Then ignore latency. So designers, I've said it before, I'm saying it again. We never used to think about latency in design, but with AI tooling, you have to think about it now. You have to design for latency. You have to know that when I click on a button, it may take some time for the user to get a response. And if that happens, what do I use to engage my user so that it doesn't lose interest and log out and just say this app is useless, it's always taking time. So this is something that requires creative thinking. Then trusting the model output blindly, don't do that, both from a developer designer standpoint. We need to be able to know when the model is confident of its outcome or its output and mark it. And when it's not confident, but even when it's confident, there's hallucination. Or hallucination means the model is actually wrongly confident of the outcome. It wouldn't be called hallucination if the model told you, hey, this is what I think it is, but I'm not sure, right? Then we also know it's not sure. It's not a hallucination. But a hallucination is, I am sure that, this thing is black in color. I am sure that there are 3 hours in strawberry. Well, okay, are there 3 hours in strawberry? Uh, there are 4 hours in strawberry. I'm sure there are 4 hours in strawberry. Okay, anyway, so then skipping evaluation. Yes, there should always be a way to evaluate the model. So from a designer standpoint, there should be a way to get feedback. If you look at ChatGPT, you notice that at the bottom of each conversation, there's a thumbs up and there's a thumbs down, right? Apart from the additional icons, right? So let me just this is it, right? So how many people actually do this? This is something to remember. I'm going to paste it here and then just you know bring back the slideshow back up, right? This is what you see. This is just an example, and I'm sure they all have this, right? There should always be a way for a user to rate or to give some feedback on an AI response. You should always have this. This allows us to create an evaluation loop. Evaluation loop essentially is where I collect user feedback to say, okay, my AI gave me a good response, or my AI gave me a bad response, so that we can use that to improve the AI. So we should not skip evaluation, right? So the biggest mistake, one of the biggest mistakes you can make, both as a designer and even as a developer, architecting a tool, is to design the AI before you understand the user workflow. You have to understand the user workflow first, and then you design the AI around it, right? And when I say design the AI, I'm not talking about the large language model or the models themselves, which have already been trained. Well, you can fine tune if you need to, but the scaffolding around it, remember the LLM is just a reasoning layer, right? You design around it. Do I need a RAG or not? Do I need two calls? What kind? Of course, you always need two calls. What kind of two calls? How do I set up my two calls? Right? How do I do two selection? Right? The RAG itself, how do I put data in it? How do I pull data and always and other things like that? So always start with the problem. If you don't, then that is the mistake. So I will end with this. I wanted us to do this class exercise. Um, we don't have a lot of time, but I'm going to look for an app, right? And I'll just put the interface here and I'm going to ask. In fact, let me pull it from let's pull it from KodeCamp. This is KodeCamp, right? I'm going to pull an interface from this KodeCamp LMS, okay? And I would like suggestions. You can chat on it or something. How can we improve this? Just a single screen. Um, we're not going to go too much. Um, if we had enough time, maybe we could have tried like two or three screens, right? Um, yeah, so I'm going to just screen grab this. I could have gone to the real site, or maybe I should go to the real site so that, yeah, let's go to the real site, okay? So that we can look at it, right? So yeah, we'll have to do app notes, app analytics, email client, anything, but I'm going to choose a code camp, right? Let's see how we can improve it. Where do users spend cognitive effort, right? That's the first thing. Identify the friction. Choose the right pattern. What should we do here? Copilot, autocomplete, or recommendation. Then we can look at the architecture to design. What does the AI need? At least if we choose any of this, right, then what does the AI need? Data, tools, or memory? Then step 4, right? We can, I just want, some discussion around it. So let's go to the code camp, right? LMS. Let's use the LMS as an example. I'm going to log in with my account. And so let's start with this screen. In fact, let me, um, yeah. So this screen is the dashboard, right? Let's start with the dashboard. So here's the thing, right? The original design of this dashboard, we have the dashboard, we have a calendar, we have training progress, okay? And then I have this long list of submissions, which I've never looked at this long list of submissions before. Like I have never looked at it because it's first of all, it's hidden below the line. It's hidden below the line. And it's so long. All of the submissions of everyone right from the beginning of the cohort. Okay. And of course it tells me the task and it tells me the status. So ideally, I think it was meant for me to know how many people have how many submissions I have not yet graded, something like that. But I never look at this because if you look at it, I don't, it's so much and it's below the line. This is the line. I don't even get to see it. And then, of course, we have this sidebar. So I want to ask designers, each person, each of you on this chat, what would I, what can we change about this, especially with the context of AI, right? Where do I spend most of my cognitive effort on this site, right? What would be the right pattern to apply here? Should I have a co-pilot on this dashboard page or not the whole of the KodeCamp? I'm not even talking of the whole of the LMS, but just on this page. Should I have a co-pilot? Should I have an autocomplete or should I have a recommendation? You can type your answers in the chat. So we'll start. This is one. Now, um, let's see. Where else should I go to? Maybe I should go to task. Should go to um, classroom. Yeah, so classroom is where I create lessons. Okay. So creating lessons. I have to create lessons. This thing is tough for me because it means that after I finish each class, I have to come here and upload the previous lessons. Okay. And the previous lessons, if you look at this, this is how one lesson looks like. Basically, it contains a link to the video on the YouTube channel, objectives and resources. And I spend a lot of time doing this. As a matter of fact, I've not even updated this thing since stage 4. This is for machine learning core class. For the AI for developers, I don't even think I've been able to update this, right? So look at this. How can we improve on this, right? Most of my cognitive effort is not really cognitive. It's more of the time I spent, building it, right? Um, you know, so should this be a copilot or autocomplete or recommendation? Right. I'm not getting responses. Only one person has responded. Now let me try something. Let me log in with a different account. I have a student account, which I just use just to ensure that student stuff are okay. So let me log in as a student now. Okay, so now I'm logging in as a student. Again, the same question. As a student, right? Um, I have again this one up here, right? Is this the most important information I should be seeing when I come in? Yes, it's summary information, but is it the most important information? Then down here, I have recent task, right? Stage 0, stage 1. Okay. So what should we have here? What is the most cognitive, what, as a student coming in here, what is the biggest challenge and I think everyone here can um, identify with that because You are all students who have used this LMS. Like, what's the biggest challenge you have here? You come here, you don't know whether there's a task, or you don't know whether you have been graded, or you don't know whether what you have been promoted, right? So, or you don't even know maybe whether a new video has been uploaded and so on. So, what kind of um pattern, if we were to do, first of all, if we were to do AI in here, what should we add, right? What would have improved, you know? I now have my task here. I've only submitted the first one. I did not I did not submit the second one, right? Um, I didn't even have enough time to do task talk later of submitting it. But anyway, right? Okay, if I wanted to submit a task, um, is there something that can be done to help me with submitting the task, right? So, somebody is suggesting that for student recommendation system, if we are doing a recommendation system, what would we be recommending? This works if we had lots of courses, right? For people to register and say, okay, you can try this course or you can try that course. Okay, somebody says calendar should be replaced with your grading status. Okay, so anyway, um, let's say, so this is LMS, right? LMS doesn't really have a lot. Okay. But if we were to have a to-do app, right, or a notes app, you know, what would be the right pattern to follow? So these are just exercises um I would like people to think about. I'm actually going to share it so it will be something for us to just think about and play around with. So with that, I come to the end of the class. I hope we enjoyed it. Are there any questions? Are there any questions or comments? I'm going to stop the recording now.